now that we've got a system, we've got to describe it. So let's describe the system now. It turns out that when you're talking about macroscopic properties of matter, you don't need very many variables to describe a system completely thermodynamically. You just need a few macroscopic variables that are very familiar to you, like the pressure, the temperature, the volume, the number of moles of each component, the mass of the system. If you've got a magnetic field, maybe the magnetic susceptibility, the electric field. We're not going to worry about these magnetic fields or electric fields in this class. So pretty much we're going to focus on this set of variables here. You're going to have to know, when you describe the system, if your system is homogeneous, like your coffee with milk in it, or heterogeneous, like water with an ice cube in it. So heterogeneous means that you've got different phases in your system. I'm a heterogeneous system. Soft stuff, hard stuff, liquid stuff. The coffee is homogeneous, even though it's made up of many components. Many different kinds of molecules make up your coffee. There's the water molecules, the flavor molecules, the milk proteins, etc. But it's all mixed up together in a homogeneous macroscopic fashion. If you drill down at the level of molecules, you'd see that it's not homogeneous. But thermodynamics takes a bird's eye view. Looks pretty uniform. Okay, so that's a homogeneous system. One phase. You have to know if your system is an equilibrium system or not. If it's an equilibrium system, then thermodynamics can describe it. If it's not, then you're going to have trouble describing it using thermodynamic properties. Okay? Thermodynamics talks about equilibrium systems and how to go from one state of equilibrium to another state of equilibrium. And what does equilibrium mean? It means that the properties of the system, the properties that describe the system, don't change in time or in space. So if I've got a gas in a container, the pressure of the gas has to be the same everywhere in the container. Otherwise, it's not equilibrium. Right? If I place my container of gas on the table here and I come back an hour later, the pressure needs to be the same when I come back. Otherwise, it's not in equilibrium. So it only talks about equilibrium systems. What else do you need to know? You need to know the variables. You need to know if it's heterogeneous or homogeneous. You need to know if it's in equilibrium. And you also need to know how many components. You have in your system. So a glass of ice water with an ice cube in it, which is a heterogeneous system, has only one component, which is water, H2O. Two phases, but one component. Latte, which is a homogeneous system, has a very, very large number of components to it. Right? All the components that make up the milk, all the components that make up the coffee, and all the impurities, etc. Cadmium, heavy metals, arsine, whatever there are in your coffee.